Chapter 7, Lesson 3, Solve Linear Systems by Adding or Subtracting. This is commonly called the elimination method, and actually this is my favorite type of method of solving a system of equations. And remember, solving a system of equations is just figuring out where the two lines cross. So what we're going to do is just look at a couple of examples, and then I think it will make sense. So the first thing you need to do is you need to set up the actual equations so the x's are above the x's and the y's are above the y's and the constants are above the constants. And what you will notice here is that for this set of equations, 2x plus 4y is equal to 2 and 4x minus 4y is equal to 16, that they both have a 4y in there. So what I can actually do is, because one is a 4y and then there's one is a plus 4y and one is a minus 4y, is I can add these two equations together, and that's what's happening here. Because whatever's on one side of the equation is equal to the other side of the equation, so I'm just adding the same thing to both sides. It's not really the same thing, but it's something that's equal to the same thing, so I can add it to both sides. So if you look there, what I'm going to do is I'm going to add 2x to 4x, I end up with 6x, and then 4y minus 4y or plus negative 4y, whatever you would like to say, figure for that. That's going to leave me with 0, and then that's going to be equal to 2 plus 16, which is 18. I'm just going to solve 6x is equal to 18 for x is equal to 3. Going to substitute back in 3 into my original equation, one of my original equations. I'm going to end up with y is equal to negative 1. Let's do that again. So for this one here, I'm going to solve this linear system. And if you notice, there's 7x plus 5y is equal to 18, and 7x minus 3y is equal to 34. That's all set up nicely right now, but we're going to change this into a subtraction problem because we have 7x and we want to get rid of 7x. So this is going to end up being 0 here for the 7x's. 7x minus 7x. Then I'm going to say 5y minus negative 3y. So that's going to be plus 8y. And then that's going to be equal to 18 minus 34. So 18 minus 34, that's going to be negative 16. So then it's just 8y is equal to negative 16, so y is going to be equal to negative 2. I'm going to plug that into one of the equations up in the top, so I'll just do 7x. Sorry for that. So it's 7x minus 3y is equal to 34. It doesn't matter which one you put it in to. So it's 7x minus 3 times negative 2, because I'm just substituting this value here, is equal to 34. So this is going to be 7x plus 6 is equal to 34. So 7x is going to be equal to, well, I have to subtract 6 from both sides. It's going to be equal to 28. And so x is going to be equal to 4. So my point is going to be 4, negative 2. Plug that in and you'll see that that should work. I just want to mentally check it. And just I mentally checked it into these two, and yes, it is a solution. Let's try another one here. This one here is a bit different because you have to set it up first of all. Right now it's not set up correctly, but you see the 6x's in both of the equations. So you can manipulate this, move it around, put it in standard form. That's the way I like to do these. So 6x minus 4y, this one's already in standard form. And then my x's are next, but I have to move it over to the left side of the equation, so it's going to be negative 6x plus 13y is equal to 8. Now what am I going to do? Am I going to add or subtract? I'm going to add these two because I already have 6x and negative 6x. So when I add them together, I end up with 0 plus negative 4 plus 13, so that's going to be 9y is equal to 18. And so y is going to be equal to 2. plug this into one of these two equations. I'm just going to plug it into the second one here, so it's going to be 13 times 2, which is going to be 13 times 2 is equal to 6x. Once again, sorry for the announcements. So this is going to be plus 8. And so this 26 is equal to 6x plus 8. So subtract both sides, 8 from both sides, you end up with 18 is equal to 6x. So x is going to be equal to, okay, so it's just going to be 3 is equal to x. So my point is going to be 3, 2. Got to plug that into this set of equations. 6, I'm going to plug it into this first one here. 6 times 3 is 18, minus 4 times 2. 4 times, minus 4 times 2 is going to be 8, so that's going to be 18 minus 8, so that's going to be 10, that's correct. And then 13 times y is going to be 13 times 2, that's 26, is equal to 6 times 3. Let me make sure that's right. See, I'm resorting to writing this down now. 26 is equal to 6 times 3, which is 18, plus 8. Yeah, that's true. So both of them are true, so that's the correct point. Try another couple ones here. This one here, it's already set up. So it's going to be 4x minus 4x and 5y minus 3y. So it's going to be 2y is equal to 8 minus 0, so that's 8. So y is going to be equal to 4. I'm going to plug that back into here. So 4x plus 5 times 4, which is going to be 20, is equal to 8. So 4x is going to be equal to negative 12. X is going to be equal to negative 3. Got to plug that back into this first problem here. 4 times negative 3 plus 5y is equal to 8. So this is going to be negative 12 plus 5y is equal to 8. 5y is going to be equal then to 20, and y is then going to be equal to 4. So this is going to be negative 3, 4. That's going to be my answer. Plug it in, and I believe you will see that that is correct. So I want to do one more where I have to set it up. So let's see. So here's another one where I have to set it up. This one's already set up. So in this case here, I'm going to set it up into standard form. So neither of them are set up in standard form, so I have to manipulate them. I have to move them around. So to put this first one in standard form, I have to go ahead and move the 4x over. So it's going to be negative 4x, subtracting 4x from both sides, plus 5y is equal to 3. And the second one is going to be 7x. I have to move over the 5y by adding 5y to both sides. So plus 5y is equal to 36. I think I like the color blue better for this. Actually, we'll go with red. So now I've got it set up the right way. I can subtract from both. When I subtract from both, I got my 5y and my 5y. They cancel each other out, so I'm left with negative 4x minus 7x, so that's going to be negative 11x is equal to 3 minus 36, so that's going to be negative 33. So x is going to be equal to 3. Plug that into one of the original equations, and so I end up with 7 times 3 is equal to 36 minus 5y. 21 is equal to 36 minus 5y. Subtract 36 from both sides, you end up with 15, negative 15, excuse me, is equal to negative 5y. So y is going to be equal to 3. So my point is going to be negative 3, 3. And you should always test these out to see if it works, and I believe it does. So actually, I realized after I wrote that, it's not negative. I wrote it down wrong. So It's actually positive 3. So again, that's key to understanding. I wouldn't have known that if I hadn't have checked my answers and seen where I'd made the mistake. So 3 and 3, when I plug that in, that should work.